Hi learners, you're welcome to our fifth lesson in integrated science. And as I pointed out earlier in our last lesson, we are beginning a new topic. And this topic is diffusion and osmosis under systems. Diffusion and osmosis under system. This explains transport system, that's movement of particles, liquid or gas, from one part to another part in living and non-living things. So specific objectives. Today, you should be able to explain the term diffusion by the end of the lesson and also demonstrate diffusion in everyday life. Explain the term diffusion and demonstrate diffusion in everyday life. So now let's move straight to the meaning of diffusion. What is diffusion? Now, there are several ways of defining the term diffusion, but there are some key expressions that examiners or scientists expect that include in any definition about diffusion. So I have two definitions here. The first one reads, diffusion is the movement of particles from a region of higher molecular concentration or higher concentration to a region of lower molecular concentration until the particles are evenly or uniformly distributed. It's the movement of particles from a region of higher molecular concentration to a region of lower molecular concentration until the particles are evenly distributed. Or diffusion is the movement of solutes, molecules, from a region of higher concentration to a region of lower concentration until the molecules are uniformly distributed or dispersed. Now look at the above diagram here. It illustrates diffusion pictorially. And if you look at the first part, this is the first region and this is the second region. In the first region, we have so much of the particles. So we see the particles are at higher concentration. Now, what they're saying is that there is movement of these particles from this region where it is highly concentrated to this region where the concentration of the molecules of particles is low. So this is diffusion. And remember, it can occur in both liquid and gas. Take note, it can occur in both liquid and gas. For that reason, let us quickly move on to how to demonstrate diffusion in everyday life. So one will be about diffusion in liquid, and the other one will be diffusion in what? Air. So let's take the first experiment. Here we are dropping ink or crystals of potassium permanganates in water. Now, potassium permanganate is what we locally call blue, that we use to soak in water to wash, to rinse white dress after washing, just to give it some brighter white bluish color. So that's the potassium permanganate. So the picture speaks for itself. This is the beaker containing water, and few drops of ink or potassium permanganate solution is dropped into the beaker, and this is a stage where it begins to spread. And here it is spreading gradually. So the molecules are now moving from this region to a region of lower concentration. So this is the region of lower concentration, and this is the region of what? Higher concentration. So it keeps on moving, spreading, spreading until the particles of the ink or the magnet spread uniformly or evenly. So this is a final stage where it is uniformly what? Spread. So this experiment illustrates diffusion in liquid. Okay, I hope you have understood this simple experiment. Now let's look at another demonstration of diffusion in air. Good. So in our second experiment, we are considering spraying a perfume in one corner of a classroom. Now this is what happens if a student gets to the opposite corner of the classroom. After some time, that student smells the scent of the perfume. Why was this possible? So at the first corner, or at one corner where the perfume was released, the gas molecules move from a region of higher concentration under pressure, spread in the air towards the other corner where the concentration is very low. So this spreading continues until the whole room is what? Filled. So this demonstration of what? Diffusion in air. All right. Now the question is, what are some of the things we can do, or what are some of the factors that can affect the speed of the spread? That can affect the speed of the spread. So let's look at factors that increase or affect the rate of diffusion. Rate here means the speed at which it spread. So let's take the first one. We have what we call concentration gradient. Yes, this is a technical word, but you can understand it. It means difference between the concentrations of any two regions. Difference between the concentrations of any two regions can affect the rate at which molecules or particles will spread from one region to another region. So the diagram explains it better. This is the first region of high concentration of molecules, or high amount of molecules in a given volume of what? Liquid. And this is the second region of low concentration of what? Molecules. Okay? So what they are saying is that if the concentration difference is very wide, the gap is very wide, then we are saying that the spread will also be faster. But if the gap is very small, that is, the difference between the concentrations are not that wide, it causes the spread to be very slow. So the higher the concentration gradient, that's the wider the gap, the faster the rate of diffusion. Okay, let's move on to other factors. Temperature. Good. Let me ask this question. Putting a salt in water, that is water of ordinary temperature, and putting the same salt in another cup of water of the same volume. By this time, that water is warmer or is at higher temperature than the previous one. In which of these will the salt dissolve faster? Yes, the one with the warmer temperature. That means the higher the temperature, the faster the rate of diffusion or spread. And the lower the temperature, the lower the rate of diffusion. Hope you are following me. Then we have the next one, size of particles. Size of particles. Again, if I should have salt, the granulated salt, that's the dango, the one that in the form of gravels, that's granulated salt, is fetched into a given volume of water by you, and your sibling or your mother fetches the powdered salt of the same mass into the same volume of water, considering that all other factors are the same. In which of these two instances will the salt dissolve faster? Or will the salt particles spread faster in the water? Yes, the powdered salt will spread faster than the granulated salt. So we are saying that the smaller the size of particles, the greater the rate of diffusion. Of course, I've been talking about diffusion in water or liquid. What about the one in air? Again, large size of particles tend to be slow in movement through air than smaller size particles. True or false? It is true. So that is about size of particles. Then we have state of matter. State of matter. Now, what do you mean by state of matter? We are saying that diffusion can take place in liquid or gas, okay? So it can take place in the liquid states or in the gaseous states. Good. The question is, movement of particles in water or in liquid and movements of the same particles in air, in which of these will the spread or the movement be faster? Good, you are right. It is the air. So we are saying that particles have higher rates of diffusion in gases than in liquid. I repeat, particles have higher rates of diffusion in gases than liquid. Then we're also considering stirring. So by stirring, we mean using the spatula or spoon to stir a soluble substance, such as salt or sugar, put into a given amount of water. Now, again, if Amma decides to put the salt in water without stirring, and Kofi does a stirring, which of these containers will have the salt dissolve faster? Good, the one with the stirring. Because as you stir, you are forcing the solid particles to, collide with the molecules of the liquid. And that friction, called viscosity, will tend to break the substance into several particles faster than when no stirring is done. All right, my dear students, we are bringing an end to our lesson. Today we look at the meaning of diffusion, and principle in the definition we noted movement of molecules. That's the first key expression, and the movement is from higher concentrated region to lower concentrated region. Remember, it's from higher to lower concentrated region, and the spread happens until the particles are evenly or uniformly distributed. Then we'll move on to look at how to demonstrate diffusion in liquid and gas. Then finally, we touched on factors that affect the rate of diffusion. For our advanced learning, please read on everyday activities that illustrate diffusion. What are some of the everyday activities that illustrate diffusion? One, I can tell you that dissolving salt in water it's an everyday activity that illustrates our diffusion. Okay, so can you mention others? Yes, you can if you do further research on this. And secondly, learn or read on applications of diffusion in plants and animals. Diffusion is one of the ways or processes by which substances move in and out the cells of plants and animals. So read on this. Congratulations for coming this far with me. I wish you a happy weekend. Make sure you do the exercise. Do the exercise and present it before Sunday 21st, okay? So that I can mark before Monday's lesson. Till we meet again, it's bye.